now in this example, notice that there is a leading coefficient. And this is typically where most students and a lot of staff as well are going to freak out, and they're going to try and default to quadratic formula. But it's not that difficult, and I'm going to show you a quick trick that will make it much easier than you think it will be. So following our steps, first thing we're going to do is move that constant. So we subtract 2 to the other side, leaving us with 3k squared plus 5k equals negative 2. Now we have to eliminate that leading coefficient, so we're going to divide everything by 3. That cancels out, leaving us with k squared plus 5/3 k equals negative 2/3. Okay, so again, we're going to rewrite this 5/3 underneath the problem. All right, and here's where the trick comes in. Remember that fractions are division. So dividing by 2 is the same as multiplying by 1/2. So we can do our division here just by multiplying by 1/2. We go straight across, giving us 5/6, and then we can square that, giving us 25/36. And we add that to both sides, plus 25/36 plus 25/36. And this is now a perfect trinomial square. So you can just rewrite it and bring it down. We bring down our first term, we bring down our first sign, and the square root of our last term, which we know is 5/6. We just drop it down. On this side, we needed a common denominator. Note how I mentioned in the last video, 3 goes into 36 12 times, so we're going to multiply by 12 here, giving us negative 24/36 plus 25/36, and a final simplified polynomial of 1/36. Now we could solve, just as we did in the previous example, by square rooting both sides. This will actually have an even square root, and subtracting 5/6 to the other side. So just real quick, to get that out of the way, k plus 5/6 is going to equal plus or minus the square root of 1 is 1, the square root of 36 is 6, and when we subtract, we will get 2 real solutions. Negative 5/6 plus or minus 1/6. Negative 5 plus 1 is negative 4/6, and negative 5 minus 1 is negative 6/6, giving us negative 2/3 and negative 1. Okay. So just as with quadratic formula, if it was supposed to be a fraction in your answer, quadratic completing the square will spit out a fraction. Okay. Now, as I said, this really is the key. It changes the form of the equation from standard form to a factored form. And this is very important in Algebra 2, in that you cannot do conic sections without being able to complete the square. And we are moving more towards all students, or at least most students, taking Algebra 2, which means most of our students are going to go through dozens and dozens of problems in which they must use completing the square just to rewrite the problem into a form that can be solved. Okay, so do not gloss over completing the square. It's not that difficult. All right? It's just a 5-step process. It works out to about the same amount of work in most cases as quadratic formula. When you have a leading coefficient, it does add some extra work, but no extra difficulty. All right? So don't be afraid of it. Make sure that you take the time with your students to make sure that they really get it before you allow them to move on, because they are going to need it later. And if you have a student who is particularly questioning you, remember that you can prove that the quadratic formula is an application of completing the square. If you take generic standard form of an equation, ax squared plus bx plus c equals 0, and you use the complete the square process on it, it will work out in the end to negative b plus or minus a square root of b squared minus 4ac over 2a, which you will note is quadratic formula. I'm not going to do this. I recommend that you try it at least once, just to have it set in your own mind. I have had to do this proof a few times to get students to accept this process because they just flat out refuse to do it. Okay? But it actually is kind of a fun problem, at least to me. I am a bit of a nerd, I know. And that's really it. Completing the square, don't be afraid of it.